We're now going to turn our attention to one of the key terminal operators that's defined in RxJava's observable class. Terminal operators do two things. They terminate an observable stream, and they also trigger all the processing of operators that are defined in that stream. And here we'll be talking about the blocking subscribe terminal operator. The blocking subscribe operator has multiple parameters passed to it, and these parameters are used to subscribe to consumers and a runnable to this observable. These parameters can be used in the following way. The first parameter, which is a consumer, can be used to consume all the elements in the sequence when all goes well. The second parameter, which is called an error consumer, is used to handle any errors that occur. And then finally, the third parameter, which is a runnable, can be used to react to completion. This particular overloaded version of blocking subscribe has a subscription request that asks for unbounded demand. And what that basically is saying to the underlying publisher is send the signals, send the data as fast as you feel like, and I will be able to handle them without running out of resources. That's indicated internally by passing an integer max value to the request method on the subscription object. We'll talk about that in other ways. It's kind of an implementation detail, but just be aware that this version is not going to be exerting any back pressure. That's the key point. The signals that are emitted to this operator are represented by the following regular expression. You can have 0 or more on next signals, followed optionally by either 1 on complete or 1 on error signal, or none. In fact, you cannot emit anything at all, and that will work perfectly fine for the way in which blocking subscribe is defined. The blocking subscribe operator triggers all the processing in the chain. That's what makes it a terminal operator. And here's a simple example we'll be taking a look at later when we get to the case study at the end of this lesson, where we're going to use the observable just factor method operator to generate 4 big fractions. We're then going to use the map transforming operator to multiply each of those big fractions in that observable stream by a large constant. And then we're going to use blocking subscribe to initiate the processing and handle the various outputs. So the first parameter that's passed in here is essentially a lambda expression that handles normal processing. In this case, it's going to take each of those big fractions that have been multiplied and append them to the end of our string builder parameter that was defined earlier in our example we'll look at in the case study. If anything were to go wrong, for example, if an exception was to arise, in that case, we would have this second parameter used to append an error value to the end of the string builder. And when the 4 values are emitted and transformed by map, then the completion processing, when everything's done, will be handled by the third parameter, which in this case will simply cause the string builder to be turned into a string and displayed on the standard output. Calling the blocking subscribe operator, as the name suggests, will block the caller thread until the upstream terminates normally or an error occurs. So if you're calling this in the main thread, then that'll block the main thread. If you call blocking subscribe in some background thread, that will cause the background thread to block. Interestingly enough, there's no equivalent operator in Project Reactor. They don't have a blocking subscribe method defined in quite the same nice, succinct way as it's done in RxJava. This omission can complicate testing, especially simple test cases, until you're comfortable using something known as a step verifier. And step verifier is a testing tool that can be used on fluxes in Project Reactor. There's also some equivalent capabilities in RxJava. And so it's very useful to get familiar with using step verifiers to do testing. So that's the end of our first set of discussions about terminal operators in RxJava's observable class. We'll come back later in an upcoming lesson and talk about the subscribe operator, which is much more common for use in RxJava than blocking subscribe, because it's more well-versed and well-connected to the asynchronous reactive properties that we come to know and love from RxJava and reactive streams.